Hello students, so today we are going to start with the next agent, that is a process of transportation, page number 29, traction and saltation. So let's understand this now. This is an agent where all except groundwater traction. The material acquired by the agents is transported by rolling, pushing and dragging along the surface. The material consists of boulders and big rocks. Now over here in traction, what happens? How does the process of transportation takes place? Uh, Here they are transported with rolling or by rolling, pushing and dragging along the surface. The material consists of boulders and big rocks. Next is saltation. Saltation is often rock materials move forward by leaps and bounds, means to a greater extent, leaps and bounds through this process. Saltation is when material such as pebbles and gravel and coarse sand that is too heavy to be carried in suspension is bounced along the surface by the force of the water or wind. There are two processes of transportation, and the agent here, first one is traction, where the material here is transported by different ways, rolling, pushing and dragging, and it consists of big rocks and boulders. Then the next one is saltation. This is rock materials move forward again by leaps and bounds, where pebbles and gravel sand is too heavy to be carried in and bounced along the surface by the force of water or wind. Now transportation here. Let's understand it in simpler terms. What does this mean? If I talk about it in simpler terms, it is transportation. Traction is where boulders or stones are rolled along the stream bed by the force of the water. Saltation is where pebbles or small stones are bounced along the stream bed by the force of the water. Next we come to is process of transportation, page number 30, that is suspension and solution. Now over here the agent, what they are talking, point number 12, fine light material is carried along with water or air in the upper layer. They are very small in size. For a long distance they do not come to rest. In this, the agents are river, wind and sea waves. What happens here when suspension we talk as a process? Here the light material gets carried away because of water or air in the upper layer. And they are so small in size, that's why they get carried away. And to a long distance, they do not come to rest. Solution. The material is carried in water in a dissolved state. In areas where limestone or similar soluble rock is present, the amount of dissolved load in water is greater. The agent here we are talking about are rivers, sea waves and groundwater. Again, the process is solution. Again, what happens over here? It is carried in a dissolved state. It's already dissolved in areas where limestone, in which areas where soluble rock or limestone is present, and the amount of dissolved load in water is greater. The process of deposition takes place. See, deposition has to take place somewhere. Settle down somewhere. The sediments, the particles, the gravel, anything for that matter, whatever is being transported through different agents of erosion. So, the process of deposition takes place due to certain factors in the course followed by the agent. The velocity at which the agent is moving has a great impact on deposition. Why does it take place? It takes place due to different certain factors. The velocity at which, the speed at which the agent is moving has a great impact on the deposition. If the stream or wind slows down, the carrying capacity will decrease and the particle sizes carried and deposited will also decrease. Now, if the wind and stream are carrying down particles and they are at a reduced speed, the particles and size also carried will be less or decrease. If a stream flows faster, if the speed is faster, say during floods or when the river is in the mountains, then the carrying power of the stream will increase. Now, if it's in the mountain, the power of the stream will increase and the sizes of particles will increase also as well. If a stream flows faster, say during floods or when the river is in mountains, then the carrying power of the stream will increase and the sizes of particles deposited will increase as well. If there is a change in the slope of land or change in direction of flow. Now, if there is a change in the slope, elevation, altitude, or the direction, the course of direction of flow, slope of the land, deposition, that time what happens? Deposition may occur there. Wind changes their direction. Definitely, wind changes the direction. When the slope is almost absent, like in plain regions, definitely there is no slope in plain regions. The rivers are unable, in this case, what happens? The rivers are unable to carry sediments further and start depositing. On plain regions, there is no slope because it's absent, so the rivers cannot carry sediments and they start depositing there itself. Smaller particles settle more slowly than the larger particles due to gravity. Now, due to gravity, the smaller particles settle more than the larger particles. The smaller particles tend to stay in suspension for longer periods of time. Suspension means here fine-like material is carried along with water or air in the upper layer. So over here, small particles settle slowly than the large particles due to gravity, and these small particles tend to stay in suspension for longer periods of time. Smaller particles are carried away till the end by river or wind. See, there is a difference, students, when we talk about small particles and large particles. Smaller particles settle more slowly and they tend to stay in suspension for longer periods. They also get carried away, mind you, till the end of river or wind, and their deposition occurs in the later stage. An obstacle like tree or mountain or similar structure may come in between. The agents may slow down because of obstacles. Deposition may take place at such a point. Now, understanding these processes will help you see how the action of different agents of erosion leads to landform formation. These landforms are a sum result of erosional, that's wading away, transportation carried away, and depositional in settling. These processes act together or may act as singularly at different locations based on the effect of each of them. Landforms produced by different agents and can be classified as depositional or erosional landforms. And the one which is marked on page 30 highlighted, that is not there in your syllabus, so that portion we are not going to include. Simple terms, what is transportation and suspension? Again, we learned the previous things what we learned were saltation and traction. Now what is suspension and solution in simple words? Such a fine particles such as clay, silt and fine sand are carried along in the river. Solution is when dissolved materials containing minerals like calcium and sodium are carried in the water and are invisible to the naked eye. I repeat, solution is when dissolved materials containing minerals like calcium and sodium are carried in the water and are invisible to the naked eye. Now, you must have realized that not all agents of erosion are present everywhere. In the arid regions, wind is the dominant agent while river is the most common of all. Karst topography, I had spoken to you all about it. What is it? Only occurs when there are dolomite or calcium rocks. There are many factors which control the formation of landforms. They are climate, type of rocks, intensity of erosion, the slope of land, and obstacles. These factors affect the process of erosion and deposition and the process discussed above. For example, the wind starts depositing when it is not able to carry the heavy load of the sediments. We saw that heavy load cannot be carried. Thus, the process of forming depositional landforms begins. Rivers start depositing when their speed reduces. Though all agents of erosion are not present everywhere, definitely all agents of erosion are not present. They are concentrated in particular areas and they are not present at all in certain areas. Common processes lead to different landforms through different agents. Flood plains are formed due to deposition by rivers, while drumlins are formed by deposition of glaciers. Now, agents of erosion and landforms. Let's understand every agent works to form various landforms. The one highlighted again is not there, and find out also is not there actually. Find out famous examples of gorges and canyons. A river which is flowing water erodes rock materials, transport them to newer places and deposits them. In this process, it creates many landforms. Picking up pieces of rocks and moving them require the river to have kinetic energy, energy in motion. When it has more kinetic energy, it can pick up and move more particles. As soon as a stream begins from its origin, from the original source, it starts erosion. Now, what happens in mountainous areas? Mountainous areas, rivers flow at bigger heights, greater heights, higher speed. So, gorges are formed with steep banks and a narrow bed. For example, the gorges of river Ulhas and river Narmada. Deeper gorges are called canyons. Over a period of time, the river starts consuming its energy in transporting the material. See, when a river is flowing, most of its consumption or uh, the energy which is consumed is in transporting the material. So the bed is less eroded. However, the erosion along the banks and the slope of the valley increases. Hence, the valley with almost vertical sides become wider. There's valley widening, which we just spoke about in the last class, becomes wider, resembling the letter V. These valleys are called V-shaped valleys. I'll talk to you all about it more in detail. Sometimes water flowing over a hilly region comes down a cliff. Now, from a cliff, the water flows at a greater speed. Waterfalls commonly get formed at such locations because if you see it's at a height and it falls down from a height. When a river runs over alternating layers of hard and soft rock, rapids and waterfalls are formed. See how there are different formations taking place because of different kinds of agents of erosion. So over here, how rapids and waterfalls are formed when alternate layers of hard and soft rock are uh, run over by a river. Jog Falls or Jog Falls on the Sharavati River, Chulia Falls on River Shambal, and Vena Falls in Mahabaleshwar are some well-known examples. At the base of the waterfall, imagine a picture of a waterfall and think now we are talking about at the base of the waterfall, plunge pools can form because of constant gush of water on the rock below. So this is a very common picture what you all can see and understand that what happens. Potholes generally originate in special circumstances. In special circumstances, the generation of potholes is there, such as below waterfalls or their rocks are structurally weak. Why so potholes originate? Because where there are weak rocks, structurally, potholes are originating from there. Now, swirling whirlpool motions, the whirlwind whirlpool motion, swirling motion of the river water causes stones at the bottom to grind the bedrock and enlarge the potholes by drilling while finer sediments are carried away in the current. Potholes may range from a few centimeters to many meters in diameter and depth. Now look at the V-shaped valley over here. When we look at the V-shaped valley over here, the river erodes downwards. The sides are cut down and attached by weathering. The loosened material slowly creeps down the slope by gravity or is washed by rain water. It results in a steep side valley with the shape of V. So this is how a V-shaped valley looks, where the river erodes downwards. V-shaped valley. How do they form? This is just some information regarding V-shaped valley. Vertical erosion, last class I had spoken about, is in the form of abrasion, hydraulic action and solution. This we need to keep on repeating and understanding in every class so that it gets clear into your mind. What do we mean by attrition, abrasion, hydraulic action, vertical erosion, downward erosion, lateral erosion, whatever. The river channel results in the formation of a steep side valley. Over time, the sides of the valley are weakened by weathering process and continue vertical erosion at the base of the valley. Gradually, mass movement has been spoken about, of materials occurs down the valley sides, gradually creating the distinctive V shape. This material is then gradually transported away by the river when there is enough energy to do so. Look at the shapes of valleys. V-shaped is formed by a river, and after carving by a glacier, which shape is formed? A U-shaped. Now, when I spoke to you about gorges and canyons, just understand, look at the picture. Where are they? Where are they found? What does the word canyon mean? And where this terminology is used? Gorges and canyons refer to the same basic landform. Now, the word canyon is widely used in United States and the gorge is widely used in Europe. This is the difference. Gorge and canyon represent very deep and narrow valleys having very steep valley side slopes. Canyon have been formed through long period of time and frequent erosion from a plateau level. Gorges are mainly formed because of flow of water or lava. The walls of gorges and canyons are made up of sandstone and granite. They are made up of sandstone and granite. So I hope there's a little bit of information about gorges and canyons. Where are they widely used? What is the difference between them? What is the similarity? And some more information regarding that. Now, large potholes can be seen in the beds of river Kukadi or Nigoj in Ahmednagar district and river Indrani or Bhagewadi are often rounded up in Pune district. This happens because the rock materials carried in the flow tumble. Tumble means fall and bounce against one another. This process called attrition makes the load fine grained. It makes it road fine grained. When the river enters the plains, there is a change in the slope. The river's velocity. The velocity basically is not speed actually, it is the swiftness. Is reduced abruptly, means all of a sudden, unexpectedly. As a result, it may deposit some material on the foothills. This leads to formation of alluvial fans. Coarse sediments. Coarse means thick, not fine grained. Coarse sediments like boulders and cobbles are deposited towards the apex. As river enters the plains, the river now uses much of its available energy for transporting the heavy load. The speed of erosion is reduced. Erosion on the outer bank and deposition on the inner bank of the channel leads to formation of serpentine bends called meanders. The bends are called meanders. Now what happens during floods? These streams seek a shorter and straight path and may not meander, means may not bend. This isolates a meander. Isolate means keeps it away, isolates bend from the new flow channel of the river. If the cutoff of the meander remains filled with water, it forms a oxbow lake. Now, how is a oxbow lake formed? When the cutoff meander remains filled with water, it forms a oxbow lake. Flooding in this course increases the erosional work of rivers in the area of gently sloping plain, leading to formation of extensive plains called floodplains. So floodplains are also formed through that. The richness of the soil formed by material brought by the rivers alluvium is beneficial for agriculture to thrive here. During floods, these floodplains become inundated with sediment-filled water that deposits sediments on the sides of the river. This leads to formation of natural levees on the sides of the river banks. Minimum gradient means the inclination. Gradient means inclination, and close proximity, closeness to one another, to the sea makes erosion impossible in this region. Heavy load, reduced velocity, that swiftness, make the river break into various channels. They are called the distributaries of a river. Why are they called so? Because the load gets distributed. Here the river deposits the sediments within its channels. As a result, flows get separated. Islands are formed. So here, students, there can be a lot of questions asked based on how islands can be formed, how distributaries are formed, what are floodplains, describe a oxbow lake. So you can, there are a lot of questions which can be asked or based on page 32. This takes somewhat triangular shape. This distinct landform is called a delta. So triangular shape, when it takes a landform takes a triangular shape, is called a delta. Deltas can only form at those river mouths where the sediment supply is high. It can be formed where the sea is not very deep. Therefore, some rivers may not form delta because they do not have huge load of sediments. Instead, they may be estuaries at the sea. We'll see what estuaries are, some other things also I will get it to your notice. Look at these estuaries. What are estuaries? They are formed where fresh water meets and mixes with ocean and water. How do we see that estuaries at sea? Some rivers may not form delta because they do not have huge load of sediments, so they may form estuaries. They are found where rivers meet the sea. Estuaries are found where the river meet chemically distinct lakes. Now, here we are going to understand geographical page number work of the sea waves. Now, what is this? If you look at the picture, work of the sea waves, A, B, C, D, E, F, G is given, and you have to identify the landforms looking at them. Like running water, sea waves too erode rocks. Definitely, one of the agents of erosion is sea waves. We've seen abrasion is the most effective form of erosion by waves. Waves also erode rock material chemically through solution. Salt weathering is particularly significant in coastal areas. If a steep coastal slope continues deep beneath the water, the impact of waves may break the rocks. Sea cliffs are carved where waves strike directly against rocks. The softer the rock along the coastline gets eroded first. Sometimes waves can erode the softer part and make it hollow enough to be called a cave. A sea arch forms when waves erode a layer of rock underneath a layer of hard rock. If a sea arch collapses, I will show you some pictures relating to sea arch, sea caves, what are the different landforms which are formed due to the agent of erosion called sea waves. A sea arch forms when waves erode a layer of rock soft underneath a layer of hard rock. If a sea arch collapses, falls down, it creates a sea stack, which looks like a large rock in the middle of water. Sea arches also result where two caves meet from each side of a headland. Surfaces at the base of the cliffs are called wave cut platforms. Extensive platforms are developed where the rocks are least resistant to wave erosion. This happens due to abrasion. They are visible at lower water levels, such as low tide. They are also proof of cliff recession. The most common landform of coastal deposition in the beach is in the beach. The part of land projecting into the sea is called headland. The part of land projecting into the sea is called headland. The coast between two adjacent headlands is concave in shape. The eroded particles are brought by the waves and deposited in the ocean. Besides the rivers, what is here we are trying to understand how do the sea waves work. So the eroded materials are brought by the waves and deposited in this portion. Besides the rivers and other agents of erosion being large amounts of sediment from the land. Moreover, as these areas are shallow, they are not deep, the velocity of the waves decreases. As a result, all these different types of sediments get deposited in this area along the sea. Predominantly, fine sand gets settled along the coast between the headlands. Such sandy deposition along the coast are called beaches. Now, how are beaches formed? They have given you an answer here. Along the coastal areas in Maharashtra, long beaches have developed at Diveghar, Guhagar, Hareshwar. Now, these places are very close to Pune as in, and they are places of tourist visits. The Marina Beach at Chennai is the longest beach in India. So, how are beaches formed? Which is the biggest, longest beach? That is Marina Beach in Chennai in India is the longest beach. Now, erosion by sea waves. When I spoke about erosion by sea waves, what happens when the sea water loaded with rock fragments and sand attack the coastal rocks? It is called abrasion. So, sea waves when they attack, which are loaded with rock fragments, attack the coastal rocks, it is called abrasion. So what we are trying to understand is the different formations which take place due to the sea waves. What were they? They were wave cut platforms, sea stacks, sea stacks. Then there are salt weathering is responsible. Headland, which a part of a land which projects into the sea is called the headland. There is cliff recession happening. Then how are beaches formed? Which is the biggest beach? We have tried to understand. So this is erosion by sea waves. Then we have abrasion caused by waves picking up stone. How do these sea waves work? They are caused by waves. These waves pick up stones and hurling them at the cliff face, wearing it away. So when they are worn out or they wear it out, it is abrasion. So we need to understand what is being actually told to us about these different kinds of uh, formations because of the sea waves happening, and how do we identify the different landforms which take place or which are formed as a reason being the work of the sea waves. Attrition. Now, attrition over here, the rock particles present in the water hit against each other and break into progressively smaller particles. This process is called attrition. Any material, but usually rocks and pebbles, will become rounder and smaller over time as it collides with other rocks and pebbles. Attrition, students, I told you already where rocks get rounded off because they bump into each other, whether the rocks or the pebbles, they keep bumping into each other and they become rounded rocks. So the rock particles hit against each other and break progressively into very small particles. When they break progressively into smaller particles, it is called attrition. So abrasion, attrition, solution, all of this you need to know in all the different kinds of agents of erosion. So that's why we are repeating this to understand how are they interconnected or interrelated.